Welcome to Module 2, How a Solar Pump Works. In Module 1, Apio learned about the cost of diesel irrigation and why Joseph earns more from his farm. Now she wants answers to some practical questions. How does a solar irrigation system work? Will it work reliably? What happens on cloudy days? What does a farmer need to do each day? In this module, we will explore these questions step by step. The solar pump starts operating in the morning as sunlight increases, reaches its highest output around midday, and gradually slows down before stopping automatically in the evening. While the pump works throughout the day, Joseph is free to focus on other farm and household activities. Let's see how the solar pump works on Joseph's farm. It is 6:30 in the morning. As sunlight reaches the solar panels, they begin generating electricity. This electricity powers the pump and starts moving water through the system. To find answers to her questions, Apio visits Joseph's farm to see the solar irrigation system in action. When Apio arrives at the farm, Joseph is checking the storage tank before starting his day. As the morning progresses, the system gets to work. By the time the sun is fully up, water is already moving from the borehole to the storage tank. By 8 o'clock, the tank is filling steadily. By 10 o'clock, the pump is operating at full capacity. No engine to start, no fuel to pour, no noise, just water. So what makes this system work? A solar pump system has 5 main components: solar panels, a controller, the pump and motor, a storage tank, and the irrigation system. So in a nutshell, a solar water pumping system works in a simple sequence. The solar panels capture sunlight and convert it into electricity. This electricity flows to the controller, which regulates the power, protects the system during operation, and supplies electricity to the pump. The pump then lifts water from a borehole, well, river, or other water source and pumps it into the storage tank. The storage tank stores water during sunny hours, allowing you to irrigate when it is best for your crops, not just when the sun is shining. Finally, the irrigation system carries the stored water to your field, where drip lines or sprinklers distribute it efficiently to your crops. Let's see how solar panels should be positioned for maximum output. In all 6 countries covered in this course, solar panels are usually installed facing south to receive the maximum amount of sunlight throughout the year. The tilt angle is generally set close to the latitude of the location. Your installer will determine and set the correct angle for your farm. Solar pump output changes with the intensity of sunlight. Water flow is highest around midday and lower in the morning and evening. Storage tanks store water pumped during sunny hours for use later when crops need irrigation. Since irrigation is not needed every sunny day, some farmers choose a solar system with batteries to store electricity for lights, phone charging, or other small household needs. Ask your installer if you would like a system that provides both irrigation and household electricity. As we have learned, sunlight affects how much water a solar pump can deliver. But the condition of the solar panels is equally important. Even when sunlight is strong, dust on the panels can reduce output by 20 to 30%. This means less water may be pumped than expected. A quick wipe with a damp cloth once a week can help maintain good system performance. Keeping the panels clean helps the system make the best use of available sunlight. But what happens when sunlight itself is limited? On sunny days, the storage tank may fill completely. On cloudy days, the solar pump continues to operate, but at a lower output. As a result, the tank may fill more slowly. A correctly sized storage tank helps ensure that water remains available when needed. Now that we understand how solar pumps work, let's look at the two main types of solar pumps: submersible pumps and surface pumps. The type of pump you need depends largely on your water source. Your water source is one of the most important factors in choosing a solar pump. If your water comes from a borehole or deep well, a submersible pump is usually the right choice. It operates underwater and can lift water from depths of 100 meters or more. If your water comes from a river, pond, stream, or shallow well, a surface pump may be suitable. It sits above the ground and draws water from the source. However, surface pumps can typically draw water from a depth of only about 7 to 8 meters. This is why your water source determines the type of pump you need. Before recommending a pump, the supplier should visit your farm and assess your water source. Always ask for a site assessment before making a decision. Now that we have seen how different types of pumps move water, let's understand why a storage tank is an important part of a solar irrigation system. Back on Joseph's farm, the solar pump delivers the most water between 9 a.m. and 2 p.m. when sunlight is strongest. However, Joseph does not always irrigate when the pump is delivering the most water. Instead, he irrigates at around 5 in the morning and 5 in the evening, when evaporation losses are lower. The storage tank makes this possible. During the hours of strongest sunlight, the pump fills the tank. Joseph can then use the stored water when it is best for his crops, rather than when sunlight is at its peak. The storage tank thus improves flexibility by separating pumping and irrigation times. However, it also increases investment costs, land and construction requirements, and potentially maintenance costs. So how large should the storage tank be? As an indicative planning value, the tank may hold around 1.5 to 2 times your daily irrigation requirement. This provides a reserve for cloudy days or maintenance periods. However, this is not a universal rule. The reservoir size should be optimized based on your daily water demand, solar availability, irrigation timing, and farmer labor availability. In areas with fewer hours of strong sunlight, a larger tank may be appropriate. Your installer can help determine the right size for your farm. Now that Apio has seen how the system works, let's revisit the 4 key questions many farmers ask about solar irrigation. Now take a moment to reflect on what you have learned. Consider the following questions and think about how it applies to your own farming situation. Take your time, you've got this. Apio now understands how the system works and trusts that it can operate reliably. Her next question is a practical one. Will it work for her farm? But Apio's farm is different. Her borehole is deeper than Joseph's, and she grows different crops. In Module 3, Apio will calculate 3 key values to assess whether solar irrigation is suitable for her farm. You will calculate the same values for your own farm. Join us on this journey to learn, share, collaborate, and empower. Because knowledge powers the sun, and the sun powers our future.